All right, well, we've got this new fancy formula for computing the slope of a tangent line, so let's try it out. Here we go. So we want to find the equation of the tangent line for, let's just start with a simple function like x squared at x equals 1. So what I want you to realize is even though there's no a written on the page, the a here is 1, right? The a in the formula that we wrote down is just the x value that you're interested in. So a is 1. And so we can go ahead and say one thing instantly. If we want to find the equation of a tangent line, we need a point on the line and we need the slope. And as we've said in the past, we've always got the point. The point here is 1 comma f of 1, which in this case is just 1, 1. So that's a point on our line. That's the point where the line and the function overlap. And so it all comes down to the slope. And so let's go ahead and write down that the slope is, well, it's f prime of 1 is the notation. This means the slope of the tangent line of f at x equals 1. And this, by definition, is the limit as h goes to 0. Now, I'm going to write it and then I'm going to erase it. So the original formula was f of a plus h minus f of a all over h. But we know that a is 1. So in this case, you might jot that down if you forgot the formula. But in this case, you can go ahead and plug in a equals 1, and you're going to get f of 1 plus h minus f of 1 all over h. Now at this point, you want to simplify a little bit. You can say, okay, limit as h goes to 0. What's f of 1 plus h? And at this point, students tend to struggle a little bit. And it's fine because we don't see things like this that much. But I just want to stop for a minute, and I invite you to answer these questions with me. So if I asked you, what's f of 1, you would say 1 squared. If I said, what's f of 2, you would say 2 squared. If I said, what's f of 5, you would say 5 squared. So if I said, what's f of a house, you should say house squared. Or if I said, what's f of a fish, you would say a fish squared. And so when we get to f of 1 plus h, you should hopefully at this point say 1 plus h squared, which is exactly what it is. So this is 1 plus h squared minus f of 1 we know is just 1 squared, which is 1, all over h. And suddenly, this is really cool, suddenly we've gone from this strange limit of slopes of secant lines to something that seems really familiar. We've studied limits like this back in 1.4 and 1.5. And you can tell that the form, let's go ahead and write this down, the form of this limit, just so we're clear, is 0 over 0. Make sure you can see it. If you just plug in h is 0, you get a 0 upstairs and a 0 downstairs. So the form is 0 over 0. This means more work. And so the trick that we've seen in the past is to expand everything and then simplify and then hope for good things. So we can learn some hope in this class. We're going to hope for something nice here. So limit as h goes to 0, I get h squared plus 2h plus 1 minus 1 all over h. And we can see that our hope is not in vain because the 1's cancel. H goes to 0, h squared plus 2h over h. H is going to 0. It isn't equal to 0. And so I can actually cancel an h. And so I get the limit as h goes to 0 of just h plus 2, and now all of a sudden we're good because this is a polynomial. So at this point you've reduced the limit from something that is indeterminate down to something that you can just use the direct substitution property and you get out a 2. And so the moral of the story is f prime of 1 is 2. That's our slope. And so now if we're going to write down the equation of our tangent line, we should probably label that. So the equation of our tangent line is, in general, let's write down the point slope form, then I'm going to erase it. It's y minus y1 equals the slope m times x minus x1, where x1, y1 is a point on your line. So I'm going to use that, then I'm going to come back and erase it. So y minus the y value, which was f of 1, well, f of 1 was just 1, so y minus 1 equals the slope, which is f prime of 2. My slope is f prime of 1, and we got out 2. So 2 times x minus x1. x1 was 1. And so you end up with y equals 2x minus 2 plus 1. So I get minus 1. And so there it is, 2x minus 1. That's the slope of our line. So I want to switch screens with you. I've actually got a Mathematica app on my iPad here. I've gone ahead and typed everything in for you, and you can see I'm just using the basic plot. I don't have a pointer now, sadly. You can see I'm using the basic plot function, and you can sure enough see that at 1, the yellow line, that's the equation of the tangent line we just found. It is lying tangent to x squared. All right, so let's go ahead and end this video here, and then we'll keep going in the next one.